All right, on this one, I went ahead and wrote it down here so I could have some room to write. But I'm working on part A. It gives us the amounts. I'm assuming you read it already. So right here, we need to do an ice table because we have initial concentrations. Some people were still getting confused on when to put initial, when to put equilibrium. It tells us right here. These are placed into an evacuated flask. That's our initial concentration. And then it says um, after they reach equilibrium, this much of SO3 is formed. We're a little lucky here, 1 liter. So when we divide our moles by liters, it just converts direct over because zero point 0.4 moles divided by 1 liter gives us 0.4 molarity, right? All right. So let's just put these in. So we're starting with 0.4 molar SO2 and 0.6 molar O2. We are starting with 0 SO3 and we are ending with 0, that was ugly, 0.3 molar SO3. So our changes are going to be minus 2x, minus x, and plus 2x. And so here it's pretty obvious that x is equal to 0.3 divided by 2, which is equal to 0.15. So let's go in and replace these numbers in here. So this x is 0.15. And this 2x is going to be, because it's 2x, 0.3. So 0.4 minus 0.3 is going to give me 0.1 at equilibrium. And 0.6 minus 0.5 is going to give me 0.45 at equilibrium. Okay, what was the question? We're looking for Kc. My Kc expression is, and this is why it's always important to write out the whole thing, it's the concentration of SO3 squared over the concentration of SO2 squared times the concentration of O2. Make sure you square where it's appropriate. So I'll rewrite that as 0.3 squared over 0.1 squared times 0.45 squared. No, I don't square that last one. I just messed that up altogether. Okay, 0.45. All right, when I put that into my calculator, I'm going to get 20. So my answer here is 20. The next question says, part B, what percentage of SO2 and O2 are converted to products at equilibrium? Well, here 0.3 SO2, 0.3 is converted out of 0.4. So 0.3 out of 0.4 times 100 is going to give me 75%. That is for SO2. On this one, we're going to do the same thing. We're going to say 0.15 over 0.6 is equal to, and I believe, I'm going to double check, that's 25%. Oops, times 100. I'm sorry. It's just automatic with a percentage, right? We multiply by 100. 25%. And that is how much O2 was converted. That's the percentages of those two.